Today is day 1 of Unit 5, so we started Unit 5 today. We started with, we just actually got right into the lesson for today. So go ahead and copy this into your notes. So we have our definition of a polynomial. A polynomial is a function that can be written in the form y equals a times x to the nth power. Now, it's either just one term like that, or it can be a sum of terms that are in that form. And now let's make sure we understand what that form looks like. So it says n is a whole number. So the exponent has to be a whole number. And if you recall, we studied whole numbers earlier in the year. We know whole numbers are 0, 1, 2, 3, 4, so forth. So no fractions, no decimals, no negatives. But 0 is included as a whole number. So if it's a term that's in that form or a sum of terms that's in that form, then we call it a polynomial. So we have several different examples here that we're supposed to figure out if they are polynomials. So the first one, we have 2x, so the exponent there's a 1, that's a whole number. So that piece, that term is good. It's considered, it makes it a polynomial, but we have to check the other term as well. So we have 1. Now, usually students say, when they first see that, they say, well, there's no exponent. So there's no variable and there's no exponent. So that can't be a polynomial. Well, reconsider that a little bit if you were thinking that. 1 is the same thing as me saying 1 times x to the 0 power. Because anything to the 0 power is 1, and 1 times 1 is 1. So 1, even though it's not written as 1x to the 0, it actually equals 1x to the 0. 1x to the 0 and 1 are the same thing. So because 0 is a whole number, then this equation, y equals 2x plus 1, is a polynomial. Okay, so is it a polynomial or not? Yes, it is. Okay, so just be careful with that. When you have that number on the end, that actually is x to the 0 power times whatever that number is. So it actually is a polynomial. Next, this one here. So our variable, our exponent is a variable this time, and polynomials do not have variable exponents. So no, because of the variable exponent. The next one, the exponent is a 2. That's a whole number, so yes. The next one, we have exponent of 3 and an exponent of 2. Both of those meet the requirements of being a whole number, and those terms are being added together. So yes, this is a polynomial. So far we have a linear equation and we have a quadratic equation, and now we have a cubic equation. All of those we're saying yes to. Those are all polynomials. So just realize the functions we've discussed previously in this course, quadratics and linears, those are also polynomials. Okay. This one, we know that this is a quadratic equation. Quadratic equation, if I were to multiply this out, and I think about all those terms, I'm going to have an x squared term, an x term, and a constant number on the end. So if I think about all those terms, they meet the definition. So yes, this is a polynomial because it's a quadratic equation. Next one, I see that half as an exponent. That tells me no, half is not a whole number. This one, it's a little harder to figure out, but you have to remember something that I taught you earlier in the year, and that is a square root is the same thing as the 1/2 power. So written in that form, we can see the 1/2 is not a whole number, so that's a no. Next, if I multiply this out, I'm going to have an x squared times an x. And I'm going to have an x term times an x, and I'm going to have just a constant times an x. So all those terms fit the definition that is a polynomial. It's actually going to be a cubic polynomial. The next one. Again, you have to remember something you were taught, and this is actually in pre-algebra when you were taught exponents. When you have a rational expression, a variable in the denominator of a fraction, you can rewrite that as whatever was in the denominator to the -1 power. These are equivalent. And if we look at it in that form, it's easier to tell that this is no because -1 is not a whole number. Okay, the next thing we talked about is standard form. Well, we already know what standard form looks like for a quadratic equation. We know it's that. So I can write standard form for any polynomial. So a cubic would look like that. And hopefully you're seeing the pattern here. We start by writing the highest exponent first, and then the exponents descend or go down by the exponents. So standard form means highest exponent first, and then decreasing exponents. Okay. Now, when a polynomial equation is written in standard form, its degree is very easy to find. First of all, let me define degree. So degree means the highest exponent. So if I'm looking at a polynomial that's in standard form, like this first one, for example, I just have to look at the first term and look at the exponent, and that is the degree. So this first equation here has degree 1 because the exponent is a 1 for the first term, or for the leading term. So again, once it's in standard form, just look at the exponent of the first term. This is degree 2. Next, degree 3. Now, the last two here, they're not in standard form. So I need to get them in standard form, or at least think about what they would look like if they were in standard form in order to figure out the degree. So in other words, I have to figure out what the exponent is for the leading term for the x. So if I take x and square it, I'm getting x squared, and then I multiply that by 3, I'm getting 3x squared. I don't actually really care about the other terms because that's going to be my highest term. So 3x squared, that means this is degree 2. Next one, same idea. We're going to either multiply it out or at least think about multiplying it out. Taking the x and squaring it gives us x squared times a 2x is going to give us a 2x cubed, which means the highest power is a 3, so this is degree 3. All right, so the next thing we need to do is we need to classify polynomials by their degree and number of terms. Before we can do that, I need to give you some notes on that. So let me just put that in the space right here. So if we classify by degree, if a polynomial has degree 0, that is a constant. That's that number on the end. Like this, for example, that 1 on the end, that's called a constant because it's 1 times x to the 0 power. So the degree of that is 0. So that would be called a constant. If it has degree 1, meaning it's to the first power, then we call that linear. If we have x squared, we know that's called quadratic. Some of these you already know. If we have to the third power or third degree, we know that's called cubic. If we have to the fourth power or degree 4, that's called quartic. And fifth degree is called quintic, or some people say quintic. And if it's sixth degree or above, it doesn't have a specific name like each of these do. We then, we just say whatever degree. So we'll say like 6th degree, 7th degree, 8th degree, so forth. Okay, so 6 or above, there's not a specific name. Now, we can also classify polynomials by their number of terms. So if a polynomial has just one term, we call that a monomial. And again, these should be somewhat familiar to you. 2 terms, that's a binomial. 3 terms is a trinomial. And if there are 4 or more terms, then we just say it's a polynomial of blank terms. So however many terms there are. So if there are 4 terms, it's a polynomial of 4 terms. If there are 5 terms, polynomial of 5 terms, and so forth. Again, no specific name for 4 or higher. So we're going to put those 2 words together, the degree word first and the number of terms word second, and we'll use those to classify these polynomials. So we can see here I have degree 1 and I have 2 terms. So because the degree is 1 and I have 2 terms, I'm going to call that a linear binomial. Next, I have degree 2, so that's quadratic, and I have 1 term, so that's a quadratic monomial. Next, degree is 3, that's cubic, and 2 terms, so that's binomial, so cubic binomial. Next, now I need to at least multiply this out enough so that I can see how many terms there are and what the degree would be. So if I square x plus 1, I know I'm getting x squared plus 2x plus 1. And then I'm distributing that 3. Now I can tell that the 3 is not really going to change the number of terms or the degree, so I'm not even going to bother multiplying it out. I can see that the degree is 2, so quadratic, and there are 3 terms. So trinomial. Next, same thing, I kind of have to at least think about what we would get if I multiplied it out. So I'll go ahead and square the binomial, which I've already done on the last one. It's the same. And then I'll think about distributing a 2x. Well, distributing a 2x doesn't affect the number of terms, but it is going to affect the degree. So 2x times x squared is 2x cubed, which means degree 3, which means cubic. And there are 3 terms, so that's a trinomial. Okay. Next, so here we have an equation that's written in factored form, and we're supposed to get it into standard form. So if you recall how we did that in the last unit when we had factored form for quadratics, we multiplied it out to get it in standard form. That's exactly what we're going to do here. So I've already a couple times now squared the binomial x plus 1. So we know that's x squared plus 2x plus 1. And we have to multiply that by the quantity x minus 5 and 2x. Now, you remember with multiplication, order does not matter. However, there probably is a smarter way or smarter order to multiply in. It's probably best to multiply the binomial and the trinomial first, and then last just distribute that 2x. So that's what we're going to do. Now, when you are multiplying a trinomial and a binomial, remember you have to distribute all the first term to all 3 terms of the trinomial and the second term of the binomial to all 3 terms of the trinomial. If that's confusing for you or you think you're going to forget something, remember a generic rectangle is always an option. I'm making a 3 by 2 generic rectangle because I have a trinomial and a binomial that I'm multiplying. So x squared plus 2x plus 1 times x minus 5. So x times x squared is x cubed, 2x times x is 2x squared, 1 times x is 1x, negative 5 times x squared is negative 5x squared, negative 5 times 2x is negative 10x, and negative 5 times 1 is negative 5. So combining like terms, I have x cubed, negative 5x squared, and positive 2x squared is negative 3x squared. Negative 10x and x is negative 9x, and then a minus 5 on the end. So I'll bring that back to my equation here. I have a 2x times that whole expression, x cubed minus 3x squared minus 9x minus 5. So now I can go ahead and distribute that. So 2x times x cubed gives me 2x to the 4th. 2x times negative 3x squared gives me negative 6x cubed. 2x times negative 9x gives me negative 18x squared. And 2x times negative 5 gives me negative 10x. Now, when I did that, I purposely put them in order as I was multiplying so that I don't have to rearrange the order. They already are in descending order, which means it's in standard form. So now that I have the equation in standard form, all I have to do is classify by degree and number of terms. So the degree is 4, and the number of terms, there are 4 terms. So I would call this a quartic polynomial of 4 terms. Okay, so the next thing we looked at was, this is a review question, how do I find the x-intercepts? Well, we remember, hopefully, that we put 0 in for y and solve for x. So this is a quadratic, which we're quite familiar with. We know we can solve that by factoring, possibly, which this one does factor. Or if I didn't factor, we know solving by completing the square or quadratic formula. So I'm going to go ahead and solve this. Really, that's just x plus 1 2 times. So that means x is equal to -1 twice. Later in the unit, we'll talk about the significance to that, why we're getting -1 twice. But you don't have to write it twice. And then I just have to write that as a coordinate point. -1, 0 is the x-intercept. Okay, so we're going to take that same idea and we're going to apply it here. These say find the roots or the zeros. Now, if you recall from yesterday's lesson, I told you that when we were using the graphing calculator to find the x-intercepts, if you recall, we went to the menu that was called, we did second calculate, and then we looked for 0. And I told you 0 is another name for an x-intercept. Well, so is a root. Root or 0, they mean the same thing. They mean the x value of an x-intercept. Okay, so in the previous problem, we found the x-intercepts and we wrote those as coordinate points. Well, roots and zeros, you actually don't really want the 0 with it. You just want the x value. So the x value that make the x-intercepts. But I am still going to put 0 in for y because that's how we find roots or zeros. This one's already factored for us. So we can just set each of those factors equal to 0. And solve for x. So we're getting x equals 5, x equals -1, x equals 0. Now again, because it asks for the roots or the zeros rather than the x-intercepts, I'm just going to write them as x values. I'm not going to write them then as coordinate points. If it said find the x-intercepts, I would be writing them as coordinate points. So same thing here, we'll put 0 in for y. Now I need to solve this one because it's not factored for me. So in order to solve it, it's a cubic. And I told you in the previous unit, the only way you know how to solve cubics is by factoring. So I'm going to go ahead and group. I'm going to pull out the greatest common factor. I copy that binomial. I figure out what that needs to be multiplied by. Looks like -25. I look at those two terms and realize that 2x plus 1 is the greatest common factor, so I write it only once because it's the greatest common factor, and then I'm left with x squared minus 25. We know from our previous factoring experience that that factors further. And now I'm ready to solve for x by setting each of those factors equal to 0. And I should be getting x is equal to -1/2, +5, or -5. Now again, those are the roots and the zeros. I'm not going to write those as coordinate points. That takes care of our lesson for today. So for tomorrow, you should complete pages 1 and 2. Stay on top of your homework just like last unit. We are into the more difficult stuff now. So it's important that you do what is assigned each night as it's assigned. Don't fall behind. Also, a reminder, if you're interested in participating in the Angel Tree, I'll be collecting money up until next week on Wednesday. It's a great cause to help out students in our community. So if you can contribute, I would appreciate it.